Welcome to this explainer. We're diving straight into exactly how to survive a catastrophic AWS data center outage by evolving from a fragile, localized setup into a massive, continent-spanning architecture. If you've ever wondered how the internet's biggest applications manage to stay online, even when entire cloud regions go completely dark, you're in the right place. We're going to uncover the exact mechanics of multi-region failover using DynamoDB and Route 53.
To really grasp the scale of this problem, picture this: a grand Victorian library in London. It's the kind of place where pure code craftsmanship is basically a religion. We've got Timothy, a junior engineer, kicking back with his coffee, feeling pretty untouchable. He's literally telling his senior colleague, Margaret, that his system is invincible. He firmly believes that even if half their third-party vendors vanished for a month, his setup is bulletproof.
And honestly, you can kind of see why he's so confident. Timothy has built a beautifully decoupled architecture. His API limits are locked down, secrets are in a digital vault, and his dead letter queues are waiting perfectly to catch any failed messages. It looks amazing on paper. But he's fallen headfirst into what we call the single region trap. There is a massive looming blind spot.
Margaret, the senior engineer, just sits down, raises a single eyebrow, and drops the ultimate disaster recovery question. So, what happens if US East 1 goes down? Now, Timothy actually laughs this off at first. US East 1 is the primary massive AWS data center in Northern Virginia. To a junior engineer, the idea of AWS's flagship region going entirely offline, it just seems impossible.
But the reality check hits hard. We all know the cloud is incredibly reliable. But let's be real, entire geographic regions absolutely can and do go down. We're talking cascading power failures, a rogue backhoe cutting a physical fiber line, or massive network events. These things happen. And historically, when US East 1 goes dark, yeah, half the internet famously goes right down with it.
It suddenly clicks for Timothy. If the actual physical building is essentially on fire, all those perfectly coded single region safety nets, they are 100% useless. His API gateway, his Lambdas, his DynamoDB tables, they are all offline. Having a highly decoupled architecture doesn't mean a thing if the single physical region it lives in completely fails.
So that brings us to Section 1, Replicating State with DynamoDB.
To build true enterprise-grade resilience, we have to tackle the absolute hardest part of any multi-region strategy. We have to solve the state. Margaret breaks it down for him. Compute, like your serverless Lambdas or API gateways, that stuff is lightweight. You can spin that up in a totally different region, like Oregon out west, in literally seconds. But that compute layer is completely useless if your user's shopping cart data is trapped inside a dark offline data center in Virginia. Moving logic? Easy. Moving the actual data state? That's the real challenge. So how do we fix it? Margaret dives into Timothy's infrastructure code, his CDK stack, and makes a tiny tweak. By simply adding replication regions to his code, she upgrades his standard database to a DynamoDB global table. This is a fully managed multi-region database. Every single time a customer writes a record in Virginia, AWS natively and asynchronously copies that exact data all the way across the country to Oregon.
And here is the wild part about global tables. The asynchronous replication latency across the entire North American continent, it's typically under 1 single second. The moment a user adds sneakers to their cart on the East Coast, bam! Less than a second later, it's safely backed up on the West Coast. Now, Timothy's not wrong to point out that running a globally replicated database comes with a premium price tag. But Margaret brings up a critical metric: recovery point objective, or RPO. Basically, how much data loss can the business survive? Because Oregon has an exact, up-to-the-second copy of the entire business, their RPO is near zero. And trust me, paying that premium for near-zero data loss is exponentially cheaper than suffering through a total 16-hour blackout where nobody can buy a single thing.
All right, let's move into Section 2, Rerouting Traffic with Route 53. Okay, so the data is safely replicated in Oregon, and we've got a backup API sitting out west. But here's the catch. When the East Coast actually fails, how do we physically reroute the customer's browser? We need a traffic cop. Enter Amazon Route 53. Now, this isn't just for registering domains. It's an incredibly smart DNS web service that makes real-time routing decisions based on the actual health of your infrastructure. Here's exactly how this failover happens without anyone lifting a finger. First, Margaret sets up a Route 53 health check that constantly pings their primary API in Virginia.
As long as it gets a healthy 200 OK response, traffic flows normally. But step 2 is the tripwire. If Route 53 gets 3 consecutive ping failures, it knows Virginia is officially down. Then, step 3 kicks in automatically. Route 53 triggers a DNS failover routing policy and instantly redirects all incoming traffic to that standby API in Oregon.
Which brings us to vital metric number 2, recovery time objective, or RTO. How fast can we get back online? Because this failover happens entirely at the DNS level, no human intervention required, the very next time a customer clicks checkout, they are seamlessly routed out west. We're talking an RTO of just minutes. No waking up engineers at 3 a.m. to manually reroute things. The system literally heals itself.
You can almost see the light bulb go off for Timothy as he connects the dots here. The ultimate goal is 0. Because DynamoDB synced the cart data a split second ago, and Route 53 just sent the customer's browser out to Oregon, the user experiences absolutely 0 data loss. Sure, they might notice a tiny latency bump since their request is traveling further geographically, but the app, it stays entirely online while your competitors' websites are crashing hard.
And that leads us to section 3, enterprise-grade resilience. Let's take a step back and look at the setup Timothy just built across his map. What he has now is an active-passive setup. The East Coast is doing all the work, while Oregon is just chilling on standby, acting as a passive safety net until Route 53 detects a failure. But, as Margaret points out, if a company wants absolutely flawless, 0 downtime performance, they can evolve this into an active-active setup. That's where both regions serve live traffic at the exact same time, balancing the load and removing that failover delay entirely. Through these distinct architectural upgrades, Timothy's system is completely transformed. Combining DynamoDB global tables to handle the absolute hardest part, data synchronization, with Route 53 acting as the ultimate traffic cop, you get a true continent-spanning powerhouse. A near-0 RPO and RTO measured in minutes. When disaster strikes a massive regional data center, your application just absorbs a slight network bump and keeps right on running. So here's what I want you to think about as we wrap up this explainer. Take a good hard look at your own systems today. Your single region safety nets, those decoupled lambdas, your perfectly optimized databases. They probably feel invincible right now. But if the physical building hosting them goes completely dark tomorrow, will your application actually survive? Your architecture might be decoupled, but is it truly continent spanning?